All right, so now let's see what we just did on that whiteboard on Excel. Let me first import some data. Let me get the data in Excel, and I want to get data from, let me go for a CSV. Let me see how many CSV do I have. Okay, let me go for diabetes data. This appears to be something which is good. Let me see how the data looks like. The data is something like glucose, blood pressure, BMI, diabetes. How many? First 200 rows. Okay, fair enough. I think we can take this data. Let me take this data. Okay, and so I think it's some diabetes predictory function is being. It appears to be a variable involved in healthcare, but no worries. I think at least it appears to me is the data of all my patients over here, right? So I'm not sure that pregnancies, I'm not sure how would that help us, but I think we can probably delete this one because I don't understand this data completely in the context. Okay, so I'll go for glucose level, blood pressure level. I think this is again whatever is the level of blood pressure over here. We can go for BMI. I think we can remove this one as well because I have no idea what do you mean by this. Right, age is there, outcome and race. I think let me remove these two as well. So I'm ultimately left with 4 variables here, and I think we have close to 729 these things. Let me calculate. Let me try and understand. Okay, let me try and understand these variables slightly closely. Let me calculate the mean deviation of these. Right, I'll try and calculate the mean deviation. I'll try and calculate the variance of the data sets over here, and I'll try and calculate the standard deviation over here. Okay, so mean deviation, variance, and standard deviation. Let's see what inferences can we make. First of all, let me highlight this quickly. Let me format this so that it looks slightly better, and we can go to our view and we can say that let's not have the grid lines. I think it looks slightly better. And in this one, I probably, oops, I've taken the entire data. This one probably can be formatted as, or probably I'll just go for this. I just wanted to decide on the number of decimal points that we have. We can go for right click and format cells, and we can go for, oh, it takes indent, font, border. I think it's fine. Fill, protection, number. Okay, let be. I think what we'll do is once the number comes up over there, then we'll probably try and format. Okay, so let me go for this. So let me calculate the mean deviation of glucose level. What I'll do is, what I need to do is I'll probably create a chart over here. I think I'm doing it for glucose level. So I'll go for mean deviation for, this is my glucose, mean deviation glucose. So I'm using this particular column, I'm doing it. Right, I can do it manually. I can also do it with the help of Excel. I'll just insert a column over here so that there's a difference. I'll go for, what is mean deviation? Deviation of every point from its mean. So I'll go for this thing is equal to this particular point minus. Okay, the formula probably might confuse you right now because this is coming out to be in the form of a table. Let me select this and let me quickly convert this into a range, right? So that it doesn't look like a this thing, a table. So I'll go for something like this: glucose A2 minus the average of the same thing, right? And once I calculate this, let me fix the range for average over here so that I don't have to do it repeatedly. And one more thing, I need to get the absolute value of this thing, isn't it? So I'll go for the absolute value of this particular number because I need to take the modulus. Remember, -6 and 6 are the same thing over here. Now guys, I've already discussed what we are doing over here, mean deviation, variance and standard deviation in the previous video, link of which is given in the description. So you can go over there, you can study whatever you want to study from the previous videos, and we can then probably come back if what I'm doing on the screen doesn't make much of a sense right now. But if it is, please continue. Okay, now this is my mean deviation. I'll just calculate this, and towards the end what I'll do is I'll calculate the sum of this mean deviation. Right, this is what I want, sum of the mean deviation, which comes out to be 18,312. And now to calculate the mean deviation of glucose, what I need to do is to divide this sum by the by what? By however number of quantities are present over here, which can be easily done by using a function in Excel called as count. And I can just, using this function, I can count this. However values are, however number of values are there. Now once I do it, I can see that the mean deviation is something like this. So I'll reduce the decimal points now to only 2 decimal points. And I'll say that copy this format to the rest of the area over here. Fine. Now the mean deviation is 25.12. And I think I can go for another thing that I haven't calculated the mean over here, right guys? So I'll just do one thing. I forgot that. I'll just get this, Control X, and I think I'll have to put it up over here. I'll go for, let me calculate the mean first, right? And that leads me to formatting it again, but that is okay. So if I calculate the average of glucose level comes out to be equal to this. So my average is this. I'll format it again. I'll say that these two also should be formatted in the same way. I'll get 121.41 is my average, whereas on an average every quantity is deviating from this average 121 by 25. That is mean deviation. Okay, right? So that's what we can do, guys. This is what I think we can do. Let me insert something because I probably will have to do the same thing for formulas as well. But I think variance and standard deviation is specific formula. I'm not sure, do we have formula for mean deviation? I am not able to understand. If I go for deviation, estimates the standard deviation is the formula, but do I have the returns the average of the absolute deviations? I think yes, this is the formula that we are looking forward to. I think if I just calculate this, okay, again, so I'll go for a deviation. This is the one. Let me try and calculate the deviation of glucose, and it comes out to be something completely different, which I thought would be right. So probably this is not what I was looking forward to. Anyways, let's come back to variance. Now if I go for variance, right, this is my variance formula. I'll use the oldest formula, 2007 compatible, so that everybody can do it. Right, so this is 971 is my variance. And now if I go for standard deviation over here will come out to be, for the same data glucose, it comes out to be the same thing, 31.18, which is close to square root of 971, which is fair enough. So which says that standard variance is 971 and the standard deviation is 31. That is, on an average, we can say that, if I apply that process, if I punish the higher distant point from the other points, I think that will basically help me a lot. Now standard deviation over here comes out to be 31. If I calculate the same things over here for the entire data, okay, except I think mean is fine. I think we can calculate mean and we can drag this data and we can calculate the mean. Unfortunately, mean deviation we need to calculate one by one, so let me leave it at this point of time. But in order to understand these 4 parameters, glucose, blood pressure, BMI and age of my patients over here, there's a small case study that I'm doing. I can always say that if I look at it, yeah, standard deviation and variance. Now if I look at it, variance is quite high in glucose, fair enough, and it's not that high in blood pressure. It's not very high in BMI, but the variance is again very high in age. Standard deviation also is throwing me bigger number. Now, if I have to answer this question, where do you see the variance being high? Either it's glucose or it's blood pressure or it's BMI or age. In these 4, where do you think that data is more spread across? Now I face another problem. The problem is blood pressure generally appears to be a 2-digit number, whereas glucose generally appears to be a 3-digit number. Age definitely appears to be a 2-digit number. BMI appears to be another 2-digit number with lesser value over here. So it's like comparing income and this thing. If I compare income and age, and if somebody says that, how can we, let me do annotation over here only, on screen only. Let's say I have to compare income and age. Now, if I'm just taking it a slightly differently. If I calculate the variance and if I calculate the standard deviation of both of them, sorry, I think it goes something like this. Let me remove it from here. Let me put it up over here. Now, problem with this is I'll not be able to compare the variance of age and income over here. Because age is a 2-digit number, the variance will not be that high. But income is a 3-digit or 5-digit or probably 6-digit number, the variance will be very, very high over here. And so is the case of standard deviation. So if age let's say standard deviation of age comes out to be 25 and the income comes out to be 16,832. How can I compare these two? How can I say whether income is more spread or is age more spread? I'll not be able to comment upon it because the original quantities were different. Now there comes something called as COV, which is coefficient of variation, which says that it's okay, you can't compare the standard deviation, but you can definitely compare the ratio of standard deviation with its own mean. That is, standard deviation divided by x bar is what, or generally people write COV as standard deviation by mu. Mu is this sign for the average. So I'm now calculating another thing in which I'm taking standard deviation with the base of variance, right? With the base of mean के basis में standard deviation कितना आएगा आप उतना निकाल लीजिए. That is going to give me a good idea because mean and standard deviation, both of them will be on the same scale as far as the quantities are concerned, even if the quantities are very far apart or नेचर वाइज क्वांटिटीज बहुत अलग अलग हैं तो भी द रेशियो ऑफ स्टैंडर्ड डेविएशन एंड मीन विल रिमेन क्लोज टू ईच अदर. Okay, let me do it in Excel. Let me delete the annotation first. Okay, let me minimize the annotation as well. So if I calculate one thing that is called as coefficient of variation, we'll call it COV. COV is nothing but equal to standard deviation. Oops, I should not apply the formula. It's nothing but the standard deviation divided by the mean. Okay, and I want this in terms of percentage, and I'll format paint it over here. Right now, if I just do this, this will be equal to 26%. Now, if I drag this formula, I'll end up calculating the COV of rest of them. Now, I can see that even if age is a lesser number and the relative numbers of age comes out to be lesser as compared to, let's say, glucose level, I can still say that the variance, or I should say the spread in age, comes out to be higher than the spread in glucose because the coefficient of variation comes out to be 35% over here, whereas the coefficient of variation comes out to be only 26% over here. The least spread data is blood pressure. The highest spread data is the age of the patients. This is how I can estimate the dispersion in my data. Okay. Again, I repeat, if you have not, if you don't know what is central tendency, what is dispersion, what is their significance, what are their applications, there are links given over here. You can actually follow the playlist in which this video is there. But the individual video links are also given in the description. You can follow that as well. All right, guys. So this is my take on dispersion. This is what we had to discuss on dispersion. See you guys in the other video with upcoming topics on statistics. See ya.